Python is one of the most popular programming languages nowadays. However, many people say that Python is slow. In this video, we're going to discuss this subject. I'm going to dive into this subject. I'm going to show you many examples. And we are going to see that Python is slow. However, I'm going to show you that is not an issue if you know how to write your code. I'm going to show you how you can write your code in order to not have problems with the slowness of Python. In this video, we're going to use this class called benchmark. And this class defines a context manager in Python because it does have this enter dunder method and this exit dunder method. So this can be used as a context manager. It has here some initialization parameters like this message telling elapsed time and this format. Of course, this start time is 0. And when you enter the context manager, the timer is turned on. And when you exit the context manager, you have here the time elapsed. So this is a context manager. And I'm using here this default timer from timeit module. This timeit module comes in a Python installation and a full Python installation. So this is the class that I'm going to use to benchmark all of our examples. Okay, so I'm going to run this cell here. I'm using a Jupyter notebook inside a VS Code. Okay, so I've run this cell, and the first thing that we are going to look is a pure Python for loop. So I have here this large number, 100,000,001, and I'm going to sum all the numbers from 1 until 100 million. Okay, I'm using here the range function, and remember that this second number is excluded from this range. Okay, that's why I put here 100,000,001, because this range function will generate numbers from 1 until 100 million without this last one, because as the doc says, this is the stop number and it is exclusive and not inclusive. The start is inclusive, but the stop number is exclusive. So I'm doing here a simple for loop. I am initializing this total variable and I'm incrementing this total variable inside this for loop. Let's take a look at how long does it take to do this summation. So here we have the results. This is the total of the summation. You can verify this number in your hand calculation. It will take some time, probably more than 16 seconds, but you can verify this summation in your hand calculator. And we have here the elapsed time. Please take into account that I'm recording my screen and my computer is probably different from yours, so you may have a different value here. But what matters is the magnitude here. We have seconds, okay? We have more than 10 seconds to do this summation with this for loop. Now, let's see how long does it take to do the same summation using a built-in function. Python built-in functions, they are optimized because they have a C code under the hood. So it will probably perform better than a pure for loop. Okay, so I'm using here this sum function. It is a built-in function. It comes with Python. So you can see when I run this cell, that will probably be faster. So as we see, we have the same result and we have here 3.13 seconds. Okay, so as expected, this is way faster than a pure for loop. So we have here the first lesson. Use built-in functions whenever possible. You must use built-in functions whenever possible. And Python has many of these built-in functions. You can see in Python docs. And our benchmark class has this self.time, and we can compare the time here from this Python for loop and here from this built-in functions. Okay, so I've done here this code that will print for us how many times the built-in function is faster than a pure for loop. So we have here that this built-in function is around 5 times faster than a pure Python for loop. Okay, please remember, please take into account that your numbers here may be slightly different, but I think that the magnitude will be in the same order in your computer. So we've seen that the built-in functions are way faster than pure Python code. So whenever possible, you should use the built-in functions because under the hood, they use other languages than Python. They use C language instead of Python. So we have here a lesson that the best way to do for loops in Python is not using Python. If you take this into account, you can use third-party packages, third-party libraries to improve the performance of your code. So here we have the NumPy package. NumPy is very known for its performance doing calculations because under the hood, NumPy uses C. So we can see this in NumPy GitHub. So I'm here in NumPy's GitHub and we can see here the language that this package uses. So we have here the Python language, of course, because we need the interface to deal with NumPy. But under the hood, we have here C, C++, Fortran, so languages that are way better, way faster doing calculations than Python. So let's take a look in how long does it take to do this summation using NumPy functions. We have here the NumPy arrange and the NumPy sum. So let's run this cell and we have here 1.29 seconds. And it will probably be faster if I were not recording my screen here. We have here around 1 second. And we can compare this performance with the previous benchmarks. So let's run this cell here. And NumPy sum is 2.42 times faster than the built-in sum function and 12.18 times faster than a pure Python loop. So again, the best way to do for loops in Python is not using Python under the hood. Python here is just the interface, it's just the API. We are here with a Python code, but under the hood is not Python. That's why it's faster. Okay, we've seen that NumPy is marvelous. We can use NumPy to do very fast calculations. But there is a faster way, and this faster way is math, your math knowledge. We do have a formula for this kind of summation, and this is the formula. So we actually don't need to sum all the numbers. You just need the last one. So let's define here a function for this formula and see it's a pure Python function, but we are only using simple operations, multiplication, sum, division, so it will be as fast as possible, okay? So let's run this cell, and here we are, 0.00188 seconds. It's way faster. That's why it's important to know math. That's why math, calculus, algebra, statistics, all this knowledge is important when you are doing some programming related with science, data science, chemistry, physics, math. That's why you need to know some math. Because when you do know math, you can make your code way faster just knowing some math equations, math relations, some math trickies that will make your code faster. So let's compare this formula with the previous benchmarks. So this formula is way faster, okay? I'm not going to read all these numbers here. You can see that way faster, 1,000 times faster. You can't even compare these things. So we have here another lesson. The best way to do a faster code is to know some kind of relation that will make you avoid some for loop and avoid the use of too many calculations, no matter what language is under the hood. No matter what language is under the hood, if you know some kind of relation that will avoid iteration, that will avoid summation, that will avoid any kind of operation, or using just simple operations, it will be way faster than any other type of calculation. So if you know a math formula that can solve your problem, please use this formula. Okay, so now let's take a look at how Python deals with large datasets. Because let's be honest, no one is doing this kind of thing regularly, right? You are not summing things in your work. You're probably not summing, oh, today I'm going to sum from 1 until 1 trillion because my boss told me so. So let's take a look in an example that's probably more close to reality. Since this is a chemistry channel, I am simulating here 100 million samples of solutions with pH from 1 to 14. I want to find the solutions that have a pH between 7.35 and 7.45. Why? Because this is the pH range of blood. Okay, so I'm trying to find in this data all the samples that could be blood, okay, based in their pHs. And the first thing that I'm going to do is a Python for loop, a pure Python for loop. I'm defining here some variables for counting and total, and then I'm going to look at each value in this data, and if the value is in this range, I'm going to increment this counting and I'm going to increment the total. Okay, why I need the total? Because I want to calculate the mean. I want the mean value of these samples. Let's run this cell. So as you can see, it took 18 seconds in my machine. And we have here the amount of samples within this range, the total, and the mean. We have here 7.40 as the mean, and that value is expected because I'm using here the uniform method from NumPy. So that's expected that the mean value is 7.40 because that's the mean value between 7.35 and 7.45, and I'm using a uniform distribution. So that's the elapsed time in my computer, 18 seconds. Now let's do the same thing using NumPy. So we have here the data, and data is an array. Being an array, I can filter this array using this notation, this bracket notation of NumPy. And here I'm filtering this data for values between 7.35 and 7.45. So I have here this filter, and I can ask for the mean using the mean method, for the sum using the sum method, and I can count how many values are in this array using the size attribute. Okay, so let's run this cell. And we have here the elapsed time of 2 seconds, way faster, because NumPy does this filtering fast. Okay, that's why it took way less time than our for loop. We can see that using NumPy is almost 9 times faster than a pure Python for loop. So using NumPy in this kind of problem is almost a no-brainer. It's probably the best way to go, and that's why NumPy is used a lot when we are talking about science, data science problems, because it does calculations in a fast way. Okay, but what really matters? I'm showing you that Python is slow. You probably want to use anything besides Python for doing some math calculations, something that needs a lot of operations. But why then use Python? Because what really matters is the total cost of software development. And this means development, execution, debugging times, and resource costs. You can do a faster code using C, C++, Fortran, any other language, but the development time will be longer. And what matters is the total cost of software life cycle. That's why Python is popular, because it can be slow if you use pure Python, but you can use packages that under the hood use other languages. And the simple Python language can make the development way faster. And that's what matters, because engineer time is more expensive than CPU time. And besides that, nowadays CPUs are way faster than they were in the past. And we have the influence of external operations on code speed that can be way more important than CPU time, like network speed, database access, file system input and output. So all these operations can slow your application, even though your code is way optimized. So for most applications, these external operations will probably have way more influence on your application speed than your code optimization. And finally, what's important when we're talking about code speed is to localize performance bottlenecks in your software. You can use whatever language you want. You must know which part of your code is slow using that language and then use other language in that specific part. And that's what we usually do when we are doing data science problems. For example, when we are dealing with data science, you are not going to use pure Python. You are going to use pandas for tabular data. You are going to use scikit-learn for modeling. You are going to use NumPy. You are going to use some SciPy functions. Why? Because the bottlenecks in this kind of problem are the ones dealing with calculations, and pure Python is not good doing these calculations, but all these packages under the hood use other languages like C, Fortran that are way faster than Python, and that's what matters when we are talking about these calculations, because these calculations are the bottlenecks in this kind of software. And if you deal with the bottlenecks, you can use whatever language you want for the interface of your program. And Python is a good glue language, okay? A language that can can put together all these parts of your software in a simple and fast way. Again, what matters is the engineer time and not the CPU time. So I hope you enjoyed this video. If you did, please give a thumbs up, subscribe to the channel, and I will leave in the description below all this data. I will leave a full article showing all these details, all these values. You can see with way more details the code that I've used here. So you can click in the link in the description below. It will lead you to my website called chemistryprogramming.xyz. I see you in the next video.